Okay, Algebra 1 students, let's get started on some problems on the second page, precisely problems 10 through 14. So we have number 10, which asks which of the following is equivalent to the expression negative, the absolute value of negative 24 plus 2 minus 10. So again, whatever we have inside the absolute value, for instance, if we had negative 11, it would just equal 11. The absolute value of 11 equals 11. It's always a positive number. So we're just, in this case, have to figure out what negative 24 plus 2 is. So if I have negative 24 something, and then I add 2, that's like pushing it back to negative 23 to negative 22. And then really we're asking what is the absolute value of negative 22? Well, the absolute value of negative 22 is positive 22. But of course, our problem is the absolute value of negative 24 plus 2, which is just positive 22 minus 10. So positive 22 minus 10 is going to be positive 12, because we're just going down by 10. 22 minus 10. 2 minus 0 is 2. 2 minus 1 is 1. 12. Next, we have problem 11, which asks us to evaluate the absolute value of 2 and 5/6 plus y. That is, if y equals 7/4. So we're dealing with the joy that is mixed fractions. And we're going to make them both into improper fractions in this case. So if we have 2 and 5/6 plus 7/4, since that's, and it's the absolute value of those two things, well, the reason why we want to take those out of the mixed fraction form is they're going to be a lot easier to add up, believe it or not, if they're both improper fractions or not mixed fractions, to be more precise. So the trick here, if you don't know this, is to take this denominator, the bottom number, and multiply it by the whole number. So that's 6 times 2, which is 12. And then 12 plus 5 is 17. 12 plus 5 equals 17. And 2 and 5/6 would just be like if you had two squares, and then you had another square where you had 1, 2, 3, 4, 5, 6 different sections, and you had 5/6 of this. So you're trying to, and we can make those bigger squares so it makes more sense intuitively. But that's 2 and 5/6, which is the same thing as 17/6, because 6 times 2 is 12, and 12 plus 5 is 17. So we have 17. This equals 17 over 6 plus 7 over 4. So now the trick, since these denominators, the bottom number here, are not identical, we want to make them into one identical thing. So again, we had 6 and 4. Well, the trick here is to work with the bigger number. 4 does not go into 6 evenly, so then that's 6 times 1 is 6. What is 6 times 2? 6 times 2 is 12. 6 times 2 equals 12. And does 4, that's the question, does 4 go into 12 evenly? Well, 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, so it does. So we would use green here, multiply both sides, the top and bottom that is, by 2, and the top and bottom here by 3, because 4 times 3 is 12, and whatever we do to the bottom, we have to do to the top. So 6 times 2 is 12. So we just have, and yeah, 12 here plus 12 here. And then 17 times 2 is 34. And 7 times 3 is 21. And that's the same thing as 34 plus 21 over 12. The reason being is that the denominators are the same, so we're just adding 34 and 21 together, and we don't have to worry about the denominator because they're now the same. So then what is 34 plus 21? Well, you could think of that as 30 plus 20 plus 4 plus 1. So, because that's 3 tens plus 2 tens plus 4 ones plus 1 1. So 3 tens, just like if you had a little black. These aren't the best little blocks, but uno, dos, tres, cuatro, cinco blocks, seis blocks, siete blocks, ocho blocks, nueve blocks, and Diaz blocks. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And let me see if I can lasso this. Copy, paste, and then we got this lasso thing again. Copy, paste, paste, paste. So that's 34. And 21 is just adding these up. 30 plus 2 tens is 50, just like 3 plus 2 is 5, but it's 50. And then 4 plus 1 is 5, so it's 55. Which you could also reimagine as taking that whole thing down like this. Shit. Anyway, I think you guys all get the idea. It would be the same thing as 55. So we have 50. Let me go back to red. or whatever, green. 55 over 12. Well, we can see these are all mixed fractions, so the only one that has 12 in the denominator, like our 55 12s, is D for delta. Let's see if that makes sense. 12 times 4 is 48, and 48 plus 7, 48 plus 2 is 50, 50 plus 5 is 55, right? Because 7 is just 2 plus 5. So yeah, that would make sense. D. D is the answer. So 12 says solve and graph the solution to x plus 1 is less than 5. So we have x plus 1 is less than 5. We just want to get the x by itself, so I'm just subtracting 1 on both sides. Subtract, I like this red. Subtract 1, subtract 1. So we just have x minus 1 is just x, and 5 minus 1 is 4. So, and it says, oh, and it's not an equal. It's a less than. X is less than 4. Well, uno, dos, tres, cuatro, 4. I'm using an open circle because this is less than, x is less than 4. It's not less than or equal to 4. If it were less than or equal to 4, I'd have a solid circle, but I don't. So, and it's less than, so that means we're going in this direction. Okay, so everything that is less than 4 is x. X is less than 4. Which you could also think of as negative infinity to 4, and you'd use parentheses because it never actually reaches 4. If we had less than, if x were less than or equal to 4, then we could rewrite it as this. But it's not, it's x is less than 4. Okay. Problem 13 says 1/3 x times 9y minus 12, which expression is equivalent to 1/3 x times 9y minus 12. So we're using the redistributive property, meaning, I'm using blue, we'd go like this, and then we'd go like this. Okay. Or maybe that helps if I do a different arrow, a color in black. So we're going to multiply 1/3 times 9y. So I'm going to go back to blue for a minute. 1/3 times 9y. Well, we're just multiplying 1/3 times 9. And that's the same thing as 1/3 times 9 over 1. Now, unlike addition and subtraction of fractions, when you multiply two fractions, it doesn't really matter too much if the denominator, the number on the bottom, is different. We're just going to multiply those, and 3 times 1 is 3, and 1 times 9 is 9, so we have 9 over 3, 9 over 3y, and then 1/3, let's view to black, that's times 1/3 times 12. I just did negative 12. 1/3 times negative 12. Okay, back to black. Okay, so 1/3 times 12. We have 1/3 times negative 12. And again, you can think of that as negative 12 over 1. Negative 12 over 1. And you're just multiplying the top by the top and the bottom by the bottom. So that's, and a negative times a positive, because that's positive 1/3. Positive 1/3 is, that's positive, but a positive times a negative is a negative. So positive 1 times negative 12 is negative 12. And 3 times 1 is 3. And we now have 9/3 y times, or minus 12/3, and 3 goes into 3 once, and 3 goes into 9 3 times, 3 goes into 3 once, sorry, 3 goes into 3 once, and then 3 goes into 12 4 times. So, and, oh, sorry, we had the 3x. 3, let's see, 3, I do not like that. We're at 1/3 x. So everything I did here would be right, except we have this x in here. So when we do the 1/3 times 9y, we're just going to have 9/3 xy. And then that's going to simplify to just 3 x 3xy minus, that 3 is gone, minus 4. And 3xy minus 4 would be A. 3xy minus 4. That would be the equivalent statement. And then finally, for 14, which of the following statements is true if x equals negative 12 and y equals 8? Select all that apply. So just remember the absolute value of negative 2 is positive 2, and because all of these have x in absolute value and all of these have y in absolute value. So again, the absolute value of negative 2 is always positive 2, and the absolute value of 8 is always positive 8. So 2, since the absolute value of x is 2, 2 is less than 8. Well, less than or equal to 8, because you have the line underneath, like over there. Yeah, is 2 less than or equal to 8? Yeah, it's less than 8. It's less than or equal. It's one of those, yeah. So that works. Next one, 8 is greater than or equal to 2. Yeah, that would also be true. And again, that's because 8, the absolute value of 8, is greater than or equal to the absolute value of negative 2. And that's true because the absolute value of negative 2 is just positive 2. So, and then the next one, the absolute value of negative 2, which is positive 2, is greater than the absolute value of 8. So the absolute value even of negative 2, which is positive 2, positive 2 is greater than the absolute value of 8, which is 8. So 2 is greater than 8. No, that is not true. And then next, 8, the absolute value of 8, which is 8, is less than the absolute value of negative 2, which is 2. So 8 is less than 2. No, that's not true. 8 is not less than 2, and 2 is not greater than 8. So the C and D are wrong. But B, again, which says 8 is greater than or equal to 2, is correct. And A, which says that 2 is less than or equal to 8, is correct as well. So that's all she wrote.